Hey, what's up everybody? I'd like to welcome you to another Juice tutorial. And in this tutorial, we're going to talk a little bit about the path class. So the path class is a way that we're able to draw more interesting lines than just straight lines. Okay, so they can be curved, they can be a closed shape, they can be weird shaped lines. And so I'm just going to give you an introduction to these. So we're going to create a pretty simple project where we're able to get the mouse XY position and the last, let's just say 10 positions of the mouse. And we are going to actually draw that as a curved line. So what we're going to do is we're actually going to just move the mouse around the screen, and then it's going to draw this kind of curved line around it. Okay, so pretty simple, but a few little tricks in there that I think will be helpful. They've been helpful for me as I was creating this project. So here we go. So I've created this project here. It's pretty much a blank project. The only thing that I've done is I've actually inherited from the timer class. So this is an audio app component. So just an audio app, standalone app. And then what I've done is I've inherited the timer class here. And then if we go back up here, we will see that we have a timer that we've started, and this is going at 60 hertz a second, so this will be repeating 60 times a second. And then in my timer callback, I just have it calling repaint, which calls the paint function. Okay, if any of that is a mystery to you why I've actually done that, then you may want to go back a few tutorials and check out my timer tutorial, and that will show you all about what I've done there. Okay, so I won't go through that again for people that have seen the tutorial. So we're just going to go ahead and get started. So first thing that we're going to do, as I said, so I've got a blank screen. It's just painted black. It's got a size of 400, 400. We'll just do a real quick compile here just to make sure that it actually compiles. And we see that we just have like a little screen here and it does nothing. So what we want to do is we want to monitor the mouse positions, and then we actually want to draw a line based off of that. So, so going back to our Juice API here, so we can just go to the Juice API. So the first question is, okay, so how do we get the X and Y positions of the mouse? So I actually found a pretty cool little function here from component. So just to go through it for people that are just starting, okay, I want to keep these things fairly slow and simple. So our actual component, so our actual window that where we actually have the black screen, is an audio app component. And then if I command click into here, we will see that that audio app component inherits from public component. Okay, so it inherits from the component class, which means that any of the public functions of we can access any of the public functions of the component class. So here we are in the component class reference, and there's loads. This is an absolutely huge class, but there's one that's called get mouse XY relative. Okay, so if I click on this, then we have this function called get mouse XY relative, and what it does is it returns the mouse's current position relative to the component. And what it does is it returns a point object. Okay, it returns a point object. Now that might sound kind of complicated. What does that mean? A point object of type int. Okay, but you'll see that it's not really anything complicated here, because if we click in there, we will see that a point object is just a pair of XY coordinates. So what that does is it's a convenient way to store our X position and our Y position of our mouse in one object, rather than having to create two variables, mouse X and mouse Y, that monitor the X and Y positions respectively. Okay, so that's why it returns this point object. So what we'll do is we will go in here and we're we'll just call this in the paint function. So one thing that I'll say before I start is, of course, you know that I'm just starting out with Juice. So there are always people that know better and more efficient ways and more optimized ways to do this, or maybe rules that I'm even breaking by finding the mouse XY position in Paint. So if you have better ways, or if you have suggestions on how the code should be better, I'd love to hear your suggestions. So please feel free to leave a comment below. Okay, always open to feedback, always open to finding the best ways to do things so we can grow as a community. Okay, so as I said, we have this function called get mouse XY relative. Okay, and so I could just call that. So I could just create an object. So we'll just use the auto keyword, which automatically kind of casts our variable here. So we will call it auto position equals get mouse XY relative. Okay, so what that does is that means position is now a point of type int object, okay, which holds our X and Y position of our mouse. Okay, now just going back to the path. So this is what our tutorial is about. So it's about the path, and we want to draw a line. Okay, so we will just go through and do a very simple example of how to draw a path. Okay, just the simple workflow. Okay, so the first thing that we want to do is we want to use a function called start new subpath. Okay, so we see here that we have a start new subpath function that takes a point of type float argument. Okay, so this kind of presents a little bit of a problem in that the return type of our get mouse XY relative returns a point of type int. So we're going to need to do a little bit of conversion just to get that to a point of type float. Okay, so first thing that we'll do is we will create a point of type float object, and we will just call this mouse position, and then we will initialize this. Okay, so all we need to do here is we can do position, and then once again these hold our X and Y positions. So there's a function called get X, which gives us our X position, and a function called get Y that returns our Y position, right? So that's cool, except we see here that it says non-const expression can't be narrowed from type int to float in initializer list. So what we need to do, so it says it actually tells us in this case, which is funny for Xcode because they could just always have these really weird error messages. It says insert an explicit cast to silence this issue. So one way, so there's the old way of doing this, what they call the C style cast, which is like this. Okay, and then I will show you the new way, or the preferred way by the C++ standards committee. Okay, so that's the old way. That's perfectly cool. That'll compile. Okay, the better way, or what they call the safer way, is using this syntax called static cast. Okay, and this is, so it goes like that, static cast float, and then I just put this in parentheses like so. Okay, and then that's the preferred way, or what they call the safer way to actually do a cast. Okay, so that is how we do it, just like that. Okay, and we can actually just put this like so. That makes it nice and readable. Okay, so all we've done there is we have this function called get mouse XY relative, which returns a point of type int object, which holds our X and Y positions of our of our mouse. Now, all we're doing is we're just changing this into a point of type float, okay, object, and we're just calling this mouse position, okay, just changing the ints to a float, basically. So now we need to create a new subpath. So first thing we need to do is we actually need to create a path object. Okay, so we start by saying path, and then I will just call this my path. Okay, and then the second thing that we do is the way that this works is that we start with this function called start new subpath. So that just means what we're going to do is we're going to create a starting point for the line that we're going to actually draw. So this is just where do we want to start drawing the line. Okay, so I'm going to do my path, and then we see that there's loads of functions here. We can even try to experiment with these maybe a little bit later, but for now we're just going to do this one start new subpath. Okay, and as we said before, we have this point of type float that we needed in this as an argument, and so I'm just going to put mouse position in there. Okay, and now we've started the new subpath, which will be the position of our mouse. And then we have a function called my_path, and then this is called line2, okay? And then we could just put an end destination. So where do we want to draw the line to? So let's just try something very simple to start off with. Okay, so we're just starting at our mouse position. We're drawing a line to the point 300, 300 on our screen, and then we need to actually draw the line. So we have this function in our graphics class. So we have graphics here, so our graphics object here. So we could say g.stroke_path. Okay. And then we have two arguments that we need to take here, so we could just go through this. So first one is a reference to our path. So our path is my path, and then it says path stroke type. Now, what does that mean? So we can just go back here. We can open another tab here and see what the Juce reference says. So path stroke type. So here we see that we have two constructors here for creating this object. So we have one that takes one argument that says what's the thickness of the line. So let's just do that just to start off with, right? So I could just do path stroke type, then thickness, let's just say 5. Okay. So I've started the path at my current mouse position. I've drawn a line to 300, 300, and then I actually render the line. So one other thing that we need to do here is we actually need to pick a color. Okay, so I will just do g.setColor. So we're going to set a color for our line, and we will do colors, and then let's just say Indian red here, right? So that should be fine now. And then we're just going to build this and see if this actually works. So if this works, then we should actually just see a line from our current mouse position to the point 300 and 300. And we see that, okay? We see that what's happening is that the timer, so if we scroll down here, the timer is calling repaint. Repaint is calling all of this. Repaint is calling paint, which is calling getting the mouse position, then setting the color Indian red, then creating a path object, starting it at whatever our mouse position is, drawing a line to 300, 300, and then actually drawing the line, which we have with a thickness of 5, and we can see that right there. Okay, so notice this. So there's a couple different ways that we can actually render this line. So we have this one that's called end. I think it's called end cap style. So we can see that at the end of the line here at 300, 300, that it just kind of cuts off there like a square. So we could actually change that. So if we go back to path stroke type here, we can actually go here and we see that we have another constructor that takes 3 arguments here. So we have stroke thickness, we have this thing called joint style, then we have this thing called end cap style. Okay, so we could just open this in another tab, see what joint style says. And we see that joint style is just an enum in the path stroke type class. And then we've got these different options, metered, which means lines will be drawn with sharp joints, curved or beveled. I'll just choose curved for now. All right, so let's just go through this. So the second argument is the joint style type. So we got path stroke type, joint style, and then curved. Okay, and then the third argument. Okay, so just to go through that for our beginners. So we have this enum called joint style that's in path stroke type. Okay, so joint style is within the path stroke type class, and then we have these 3 options here. Okay, and that's why we had to do the syntax that way. Okay, and then we have this end cap style, and we have these 3 options: butt, square, or rounded. So let's just do rounded. Okay, so once again, we got it's in the path stroke type class, and then end cap style, and then it was rounded. Okay, so just to make this a little bit clearer, we can just roll it out like that. Okay, and then we should see that we're going to have rounded edges at the end of our lines. So the joint style isn't really going to matter in this case for now because we just have 2 points, so there are no points to curve along our line just yet. But we see that our end cap style is rounded, and you see that at the very end there that we have that rather than having a square edge, it's a bit rounded like that. So that's what that does. Great. So that's cool. So now let's just enhance this a little bit. So what we want to do now is we want to maybe do a history of our mouse positions and just have it draw a line that kind of follows our mouse position, and then it kind of deletes them off the end as they get too old. Okay, so how can we do that? So I'm going to show you. So first thing that we're going to do is we could store these mouse positions, right, in a history, and we could do this in a vector. So what I could do is I could just create a vector here. So we do std vector, and remember, what are we storing here? We're storing point of type floats objects. Okay, so points of type float objects. Okay, so that syntax can be a little bit tricksy to start off with, but yeah, just think about what we're actually storing in there. Okay, and then we will just call this mouse history. Okay, so that's what that is. So why is it? I think that's just Xcode doing what it does best, giving us funny little errors that don't matter. Okay, so at the moment, mouse history doesn't have a size, so we need to give it a size first. We need a way to kind of initialize this. So we can create an initialize function, and then we can just give it a size to start off with. So we can put in a size there, and then we can create this function. Right, so I'll just do it like this. I like these lines here, makes nice separation. So we got void, then this is in our main component, and then this is our function that we're creating called initialize, where we're going to initialize our vector. So in here, we can use the resize function, which is a function within the vector class to resize the vector to what we want. Okay, so we could do, so this was called mouse history, okay, the name of our vector. We could do resize, and then we just put our size in there, right? Now, one thing that I'm thinking that I probably should have looked up before I did this tutorial, I'm not sure, is when it resizes this, does it initialize these indices to 0 or to an initial value, or is it just junk? Okay, so just to be safe, what we could do, we actually have a function from the standard library called fill, where we can actually fill this with a initial value. We can just do the standard library std, or stud as some people call it, stud fill, and then we see here that we have this kind of could be a little bit confusing to look at first, but it's really not. So we have a forward iterator first. So an iterator is something that points into a part of our vector, right? And then where we want that, so where we want to begin to fill these values, where we want to end filling these values, and then the last argument is what the value of what we want it to actually be. Okay, so sometimes these standard library, the way these are written out, can be a little bit kind of confusing to look at first, but kind of get used to it. So what we want to do is we want to go from the very beginning. So we want what's called an iterator to the first index in mouse history. So there's this handy function called begin, which returns an iterator, which returns a pointer to our to the first index in mouse history. So we got mouse history.begin, and then we got mouse history.end, which actually returns. I need to actually look this up, but end, I believe, returns an iterator to the index after the last valid index. So I'm actually going to just do this on the fly just to make sure I have this right. So let's see, iterator and C++. So yes, that's right. So returns an iterator referring to the past the end element of the vector container. Okay, so we could easily do n-1, right? So that will fill it to the end, to the last valid index. And now this is where things can be a little bit confusing for people, right? Because first thing that we want to say is, okay, we want to initialize the vector to the value of 0, right? The problem is that if we look back to our header, this is not a vector of ints or of floats. It's a vector of point of type floats, okay? So which if you remember, holds x and y values. So that's why instead of that, so we need to do this. So we need a point object of type float, and then we initialize that to 0, 0, like that. Okay, so that's what's happening there. That's why we need to do it like that. Okay, because it's not taking an int, it's taking a point of type float object. Okay, so now we've initialized our vector, right? And we've given it a size, so we can actually just use this function up here in our constructor, and we can say initialize, and we'll set a value of 10, right? So last 10 mouse positions. So now we have this vector, pardon me, of mouse positions, and the size of it is 10. Now we need a way to actually get the mouse positions into this vector. So we need another function here. So we could call this maybe add to history. So void add to history. And then what do we want to add to history? Well, we want to add point of type float reference point. So this is a reference to a point of type float. Okay, so the reference just means that we aren't creating any new point float objects internally. Okay, we're just referring to the values that are actually coming in. Okay, and we can make this const, I believe, because we are just reading what these point floats are. We don't actually need to change them or anything like that. Okay, so that's why we can make this const. Okay, because const means we're just reading the value. We're not actually changing the value. Okay, I think that should work. Okay, so now we have this void. So now we're going to create this function, void main component, add to history, and then const point of type float, and this is a reference, and we will just call this point. So now we need to think of a few things here. Okay, so let's just say that we are adding into the history. So the instinct would be to say, okay, let's push back into mouse history, the mouse history vector, push back the points into the mouse history vector. Well, there are a couple issues with that. First of all, mouse history already has a size. It has a size of 10, which is what we've already set it to. So we don't need to change the size, and push back would actually increase the size of our vector. That's not what we want to do. What we want to do is we want to actually write into the existing indices that already exist in our vector. So now we say, okay, so the way we would do that is we say mouse history, then we have some index, like let's just say 0, and then we say that equals point, that equals whatever our point object is. Okay, so how do we actually take this and iterate over this, increase this? So what we need to do is we need to have some sort of variable, right? We need to have a variable that writes in there. Okay, so I'll call this write pointer. Okay, and this variable that we're going to create called write pointer, this is going to need to increase so we write into a position into the vector, and then we go to the next position, we write into that position, so on and so forth, right? So that needs to increase. So we can create an int write pointer, and we will start it off at 0. And now that will be fine. So now we need a way that we need to increase this, right? So we could just do write pointer plus plus, right? But there's a problem. So write pointer is just going to, every time we write into mouse history, write pointer is going to increase. But what's going to happen when we get to the end of our mouse history vector? Well, it's just going to go off the end, and it's going to write into invalid indices in this mouse history vector that don't actually even exist. So what we need now is we need a way that we can actually wrap this around. Okay, and so the most common way, the easiest way to do this is using the modulo operator. So if you don't know about modulo, modulo is great, and you want to read up on it. But what modulo does is it gives us the remainder after a division. Okay, and I don't want to go too far into it because there are loads of resources on it. But what it does in short is it allows us to wrap around the size of the vector. So what I could do is I could say write pointer, rather than doing write pointer plus plus, which is just going to carry us increasingly off the vector. We could say write pointer equals write pointer plus 1, then modulo, which is the percent sign, modulo the, and then we want to make sure that we're not iterating off of the size of our mouse history, right? Our mouse history vector. So we want to say mouse history dot size. Okay. So what that ensures is that we basically count from 0 to 9, and then when it gets to 10, it will go back to 0 again. So what it'll do is it will replace the oldest values of our vector. So it's a circular buffer. Okay. So if you don't know about circular buffers, this is probably the easy. Well, it is. I mean, it's 2 lines of code. This is the easiest way to write a circular buffer. Okay, just using this modulo like this. Okay, so that's what we're doing. So right pointer is 0. We're doing, and then we're saying mouse history at point 0 equals our current point, and then we are going to increase the right pointer by 1, and then we're going to use the modulo mouse history dot size to ensure that we don't walk off of the size of our vector. Now, one thing that we want to make sure is that our order of operations are correct here. Okay, so if you've ever taken a algebra class, you'll know that division, modulo, and multiplication is going to happen before addition and subtraction. So what we need to do is we need to put right pointer plus 1 in parentheses to ensure that that happens first. Otherwise, you get 1 modulo the history dot size plus the right pointer, and that's not what we want. We want this, the right pointer plus 1, and then take that modulo the history mouse history size. Okay, so now what we can do is we can actually add points to this mouse history, and we will just do this in Paint for now. Okay, so where shall we do this? So we can do this right after we get our mouse position, which we kind of do this casting function to a point of type float. So we could do add to history, and then we say this is going to be mouse position. Okay, like so. So now we've added the latest point in our mouse position to our history. And then now we're going down here. Now we just need to change some of this code to actually read into these points, to actually read into the points in our history that we recorded and actually render those, so we can actually render a line. Okay, so we could do that using a for loop. For int I equals 0, I is less than mouse position dot size. What am I doing here? Oh, not mouse history dot size. Dot size I plus plus. Okay, so like to start off with, right? We'll just do this really super easy, and this won't be quite right, but then we'll go in and we'll correct it more. Okay, so we will do my path. So we'll go back to my path dot line 2, and now we just need to get our mouse history, our mouse history elements, the indices, which are our points history, right? So we got mouse history at index I. Okay, so let's just see what happens when we do that. Okay. So we get a crash, okay? And we also saw there that, let me see if I can do it again without it crashing. So we saw there that there were 2 lines that were actually drawing. So going back here, I think that we just need to put this up here, and that should fix us. So I had that error earlier. Let's see if that works now. Okay, so we see that this is actually drawing. Oh, still getting the error. 1 second. Okay, let's see here. Okay, why is that? Oh, I know why that's happening. Okay, so the reason that that's happening is that we are reading. So what's happening is that in this for loop, we are reading from zero, so from the zero index to the mouse history dot size, right? The problem is that when is that currently sometimes the index that is the current index of the current position of the mouse and the current index that it's trying to read in mouse history are actually the same value, and that's why we're getting that funny that error that's saying angle 2 has to be less than angle 1. So it's basically like an invalid angle. So as long as I do this, I should be fine. But if I start doing no, of course now I'm not going to be able to get it to crash. But yeah, it's not going to crash for me. But the problem is that if the position that it's trying, my suspicion is that if it's the position that it's trying to read, if the position that it's trying to read happens to be the current position, then you get a crash because it's an invalid angle. That's what that error seemed to be. So that points to a problem, to one problem, which is that we have this right pointer, and what the right pointer is doing is that it's actually writing around. So what we need to do is we need to find the last 10 values from mouse history, from where the right pointer is going backwards, right? So we need to find where our current position is actually writing in the vector. So we could just do a variable here. We'll just call it current position equals. Let me think about this. So it would be right pointer plus I. Yeah, because what we want is so wherever we're at, so we're at right pointer, right? And what we want to do is we want to read the next 10 values after that, because those are going to be our oldest values, because this is going around in a circle. So if we have a vector of size 10 and our right pointer is at 5, then what we need, and let's just say this has been happening for a while, then the oldest positions in the vector, the oldest position is going to be position 6, and then position 6, and then wrapping all the way around 7, 8, 9, and then back to 0, 1, 2, 3, 4. So those are the last 10. That's the history of the last 10 positions, right? So we're saying right pointer plus I, because what we're doing is we're saying, okay, give me the history of the last 10 positions. So the last position, the oldest position, would be actually the next position in the vector, which is a bit confusing, but that's what it is. So we got oldest position plus I, but I is going to go from 0 to mouse history, so we need to make sure once again that we are wrapping around. So that's why we're going to do the modulo mouse history dot size. Okay, and then once again, order of operations. This is what we want here, like that. Okay, and that ensures that we always stay within the bounds of our mouse history size. And then we can just do current position here. Okay. Then, yeah, so let's see here. Okay, so we still have two lines there. Okay, and I know why this when I was actually creating this tutorial, this was driving me crazy, and I couldn't figure out why that was happening. I was trying everything, but I'll tell you why. So the reason why that happens is because if we look here, we say, so we create the path, then we start the new subpath, which is our current mouse position, right? So we're starting from our current mouse position, and then we're drawing points to our throughout our curve here, and we are saying current position equals, and then we're drawing a line from our current position where we started the subpath back to the oldest position. So that's why we're getting those two lines, because it's going from the current position back to the oldest position and then all the way back to the current position again. Okay, so that's why we're getting that little kind of lasso effect. So what we want in here is actually the oldest position, which is going to be this once again. So what we could do is we could do like auto oldest position equals wherever our current position is. So which would be hold on, I'm getting a little bit confused here. So we got mouse. Let me think about this. Is it mouse position? I'm getting confused with all these variables. It's right pointer. That's the one I was looking for. So right pointer. So once again, our right pointer is, if we look here, we'll actually see this is something that a person in the community, as I was making this tutorial, pointed out, which is that so the latest position would be right pointer, but then we iterate that by 1, right? We haven't actually written that. We haven't actually written this into the history. We've actually just done. We've just iterated this int called right pointer by 1. Okay, so just to make it, but yeah. So what we did is we added to the history. We iterated it by 1. And then I don't actually even need this variable. I just need to go mouse history. And then at index right pointer. Okay, that's a little bit confusing. I'm going to actually create another variable just to kind of make it logical for a person that's reading this code. I'm just going to say oldest position equals right pointer. Okay, the reason that I'm doing that is because I'm expressing here that I'm talking about the oldest position, so going back a history of 10. Okay, so that's why I'm doing another variable here. I don't know if that's like right or not. To me, it just makes sense if I was reading it, because if I had mouse history at the right position, I would be thinking that's a bit weird. I've just added that to the history. So yeah, that's the reason why I'm doing that. I don't know if that's like the proper form, but that's what I feel like doing it. So that's how we're going to do it. So let's see if that actually works. So it's the oldest position. And we can see that this now works, right? We're getting a nice curved line, and it's following, and it's doing its thing. And that's really cool. So like let's just play around with this a little bit, right? See, check out a couple little options. So like let's just change the size to 20 and see what happens there. Okay, and then we can see that we get just a longer line. Okay, just like that, and then it disappears. Okay, like so. Okay, now let's do this, right? So I've never tried this, but like let's comment this out for a second. I don't know if this is gonna work or not, but my path. Let's just see, like I don't know. I'm looking for something that takes like a just takes a point object. Okay, maybe this is a bad. Yeah, this isn't a good one. Um, yeah, so I'm not gonna do that. Sorry. Yeah, I'm not gonna mess with the arrows and stuff because then I'd have to start thinking about other considerations, which are too much for the scope of this tutorial. But let's just try this, right? Let's try the joint style really quick. And then I think one of them is called beveled. Okay, I don't know. I've never tried this. Just experimenting around, seeing what actually happens. Okay, I don't see much of a difference there. It's pretty cool though. Looks really good. Um, and what was the other one? So we got joint style, joint style, and then what's the other joint style? So let's command click in here for a second. Metered. Let's just try that really quick. Okay, and then we'll wrap this up. Okay. I mean, yeah, the connections between the lines, between the points looks a little bit more angular from what I can see. I mean, maybe. Yeah, definitely more angular. So, cool. You can change the thickness, right? And then we'll wrap this up for good. There's loads of stuff you could do. So yeah, you can change the thickness of that just like that. Cool. There's loads of stuff that we could do, and maybe we can expand off of this in the future. Maybe make this circular buffer more of a something for sound, or maybe map the mouse to sound, something like that. That could be cool. Make it change color depending on the timbre of the sound that we're playing. Something like that, something for the future. So that's where I'm going to wrap up this tutorial. So once again, this is just a little bit about drawing paths, drawing curved lines, and I hope you enjoyed this tutorial, and I will see you next time.